Today on CodeDependent, we're going to talk about interpolation. Arbitrary type interpolation is one of the interesting things about Flex 4 effects. In Flex 3, we had the ability to run effects on most objects that you would care about, position, size, all the stuff that's sort of typical in a GUI. But anything that was animated basically had to be a number. The internal infrastructure of the effects was set up such that it operated on numbers. It wanted to know what the numerical value was that you wanted animated, whether it was the position of the object, the size of the object, the representation of some value. Everything was a number. Well, in some cases, you have things that aren't numbers, or which may be numbers, but you can't really interpolate them as numbers. So in an earlier episode, we looked at animate color, which uses color interpolation to sort of split out a numerical value into R, G, and B values and then interpolate these separately. Today I wanted to talk about creating a custom interpolator for situations where maybe you have an object that we don't have an interpolator for, or you have some custom object that we wouldn't have an interpolator for because we really don't know what it is. So in particular, I want to look at interpolating rectangular objects directly. So this is a more complex structure that contains numbers, but is not a number. You could not tell our effects to immediately interpolate this rectangle because we don't know what a rectangle is. We don't know how to interpolate the separate values in it. So let's see how to make this thing work with Flex 4 effects. So if we take a look at the sample application, when you click in the canvas, it animates this rectangular object from one position and size to another position and size over time. So by default, it does this by animating 4 separate properties of that object. So first of all, let's take a look at the object itself. I've created this class called rectObject, and it basically takes a rectangular region that you specify, and then internally it creates an actual graphic object that it places into the scene. So we'll take a look at rectObject, the class. You can see it's fairly simple. It's mostly getters and setters in here. But it has this primitive object, this graphics object that it has internally. So it creates one of those on instantiation, and then it sets the stroke value at construction time. If you pass it rect value, when you construct it, it'll set that on the object. But otherwise, you basically set the x and y and width and height properties, or the rectangular region for the object directly, and then it'll set it on the primitive. So you pass in a new x value or a new height value, and it'll say, okay, I'm going to tell the primitive that its height is now this. So it's just an abstraction layer where you provide the data structure of the rectangle to this object, and then it translates from that data structure into the actual positional and size parameters of the graphical rect object internally. Sort of, cobbled together for the purposes of this demo, but, a reasonable thing that you might want to have, or something like this. And then there's a couple of things in here about getting and setting the parent, so that this class will actually add that graphical object to the scene, since the rect object itself is not a graphical object. You couldn't add rect object to the scene. Instead, it's going to add its internal graphical asset to the scene. Okay, so given that rect object that we've given some positional parameters for the 2 states that we have, then we have the states declared here, S1 and S2. We have one transition declared, which will kick in whenever we change state. So clicking on the canvas, as we see here, will change the current state, and it'll toggle between S1 and S2. And that will run the single animation that we have. It's an animate effect, which is the superclass of all the new Flex 4 effects, and it's basically a generic way of running effects on multiple properties. And in this case, we're going to animate x and y and width and height over time. It's going to grab the values dynamically from the state value, so it'll say, well, I'm in a transition. Where am I moving from? Where am I moving to? And it'll populate automatically the values for these properties that we specified. And it works. Right? There's no reason necessarily to change from this, but in some cases, maybe you actually don't want to individually animate these properties. Maybe there's some reason that you actually need to animate all of the properties together. Maybe it's more convenient, maybe it makes your code easier to read, maybe there's actually functional reasons, which we'll see in a later episode, for actually animating the single rectangular property as opposed to the individual positional and size properties for the object. So how would we go about that? Well, first of all, we need an interpolator, and in this case we have something that we call rectInterpolator, which we've defined. So we said, okay, give me a new class, implement the IInterpolator interface, which is a new interface in Flex 4. And this will spit out 3 methods here. The main one that you're concerned with, that we're concerned with here today, is interpolate. But these other two are also important. These are used internally. If you specify that you want an object to move by some value, then it needs to know how to add or subtract a value of this arbitrary type. So you need to implement these methods to say, well, given a base value to start from and some increment value, give me back the new value for this object, given those two parameters. But we won't worry about those today. Instead, we'll just look at the interpolate function here. So we get a fraction. This is the elapsed and eased fraction of the animation. And it says this is a value in general between 0 and 1. We have a start value of the object. We don't know what it is. We're just passing you in the start value that you declared for the animation. And we have the end value of the object that you told us about. Now, given the fraction elapsed, the start value and the end value, you should, for your custom type, be able to say what the value of the object is for that elapsed fraction. And in this case, we can say, okay, the value of a rectangle, this geometrical object, is going to be basically the interpolated value of the x and y and width and height values internal to that rectangle. So we basically return a new rectangle that has this calculation, the same parametric calculation on each of its component values. We say x value plus fraction times the delta between the end x value and the start x value. And same thing for y and width and height. Okay, so simple interpolator, give me a rectangle, give me start and end rectangles, give me the fraction elapsed, and I can tell you the rectangle that will result in an interpolation of that object. Okay, so now that we have our rect interpolator, we can go ahead and use that interpolator to animate this arbitrary rectangular object that we have. So let's go and see how to do that. So in our declaration section, I want an instance that I can use. So I'm going to grab that rect interpolator and give it an ID of my interpolator. And now I need an animation that's actually going to use that thing. So up here, our animate effect is animating these numeric properties. They don't care about it. But I can go ahead and simplify this animation to use one single property instead by doing this. So let's declare a simple motion path. In this case, our property is going to be the rect property of our rect object. And this is the thing we actually pass in a rectangle, this geometrical object instead. But there's one other tweak that we need here. We need to actually pass it the custom interpolator. By default, Flex effects expect numbers to be used. And if it's not a number, you need to tell us how to interpret this thing. And you do that by passing in an interpolator. So we'll grab our interpolator and we'll say the interpolator is my interpolator. And we can comment out these because we are no longer animating x, y, width, and height. Instead, we're animating the rect directly. So we click on the canvas and the rectangle animates. Same exact behavior as before, but there's two key differences. One is that we're actually doing an atomic operation, which may matter in some situations, probably doesn't in this particular case. This is just a demo. But sometimes we want to actually animate everything all at once so that the thing that we're animating has all the information that it needs to calculate its final values. So that's an important distinction. And also, the code is much more compact. So you'll see we were individually animating these things before, but now we've got this one property that we're animating, because that's really what we're doing here is we're changing the entire rectangle at once. Yes, internally it's the x, y, width, and height, but it reads much more concisely in the code to say, I am changing the rectangle over time, and here's how to interpolate those values. If you want to see the code for this and related applications, check out my blog at graphics-geek.blogspot.com.